All right, so the last lesson we did was on properties of parallelograms, and you remember we learned the definition of a parallelogram, and then we learned a lot of theorems that said if a quadrilateral is a parallelogram, then all these certain things had to be true. So what we're going to do today is we're actually going to use the converse of some of those theorems and maybe another one or two new theorems to start proving that a quadrilateral is a parallelogram. So when you get finished, go back and write your essential question, and let's just start by looking at these theorems. First one says, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. That's definitely a converse of one that we learned last time. Next one says, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Another converse. Next one says, if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. That one is not a converse, but it's very similar to what the converse of the one we learned yesterday would say. This one says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. That one is a converse. This one says if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. That one is not a converse from yesterday, but this is a really important theorem that you will have to use a lot. So again, it says if one pair, so just pick one pair. So here we're talking about AB and CD. If one pair of opposite sides is both parallel and congruent, then we don't even have to worry about the other set of opposite sides. We can say that that quadrilateral is a parallelogram. So let's just hop right in there and use this new knowledge we have to do a proof. So it says, prove that if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. Okay, we're proving the theorem from up above. So let's see what we got here. I'm going to draw J, K, L, M. And remember how I have to label my vertices consecutively. Doesn't matter which one you start with. Doesn't matter whether you go clockwise or counterclockwise. You just have to label them consecutively. All right, I got my statements. Got my reasons. I know my first one is going to be given. So angle J is supplementary to angles K and M. And I'm trying to prove that this is a parallelogram. Okay, it's not clear in my mind exactly what I have to do. So what I'm going to do is I'm just going to write down in step 2 what I know because of my given statement. So if J is supplementary to angles K and M, I know that the measure of angle J plus the measure of angle K equals 180. Let me backtrack a minute here. I was about to start writing some equality statements based on this, but I had to stop and think, and that's not really what I want to do. Let's think about this. If J is supplementary to K, all right, so I got angle K marked here. I know that J would be, let's call that X. This would be 180 minus X. J would be right. And if J is supplementary to M, and J is 180 minus X, then that would mean M is also x. And we also know that's true because of the theorem. You remember we learned this a long time ago that said if two angles are supplementary to the same angle, then they are congruent. So we know that K and M are congruent because they're both supplementary to J. And so now I've marked my picture showing that both of those angles are supplementary to J. So now let me think about this here for a second. Let's talk about J and K for a second. If I look at line KL and line JM, and let's say I used KJ for my transversal, then what does that tell me? Oh, it tells me that KL is parallel to JM, right? Because if KJ is my transversal and I see that angle K and angle J are supplementary, then I know that KL has to be parallel. KL is parallel to JM. And how do I know that? That's the consecutive interior angles converse. That would be the converse, right? And that converse also tells me that LM is going to be parallel to KJ if JM is our transversal. I know that's getting messy, but that's the truth. You might have to draw it again to the side to make sure you get it. So that also tells me that KJ is parallel to LM. The consecutive interior angles converse. And then I have it, right? If I've got that both sets, both pairs of opposite sides are parallel, then I know that JKLM is a parallelogram. So I think I've got it. JKLM is I got room, so I'll write it out. Parallelogram. And because I know that both pairs of opposite sides are parallel, that's the definition of parallelogram. So that turned out to be a little easier than I thought it was going to be. Okay, how about our next problem? A pane in a stained glass window has the shape shown below. How do you know that the plane is a parallelogram? Well, I know because of the theorem that tells me if both sets of opposite sides of a parallelogram are congruent, then the parallelogram is, I'm sorry, the quadrilateral is a parallelogram. That's how I know because of that theorem. Okay, let's see what else we got. Can you prove that the quadrilaterals are parallelograms in all of those? And then, okay, I want you to pause here and do 1 and 2. Each has 2 parts. Come back and check your answer. All right, how'd we do? On 1A, based on the given information, I can say that ABCD is a parallelogram because I know that one pair of opposite sides is both congruent and parallel. How do I know they're parallel? Oh, because if I use AD as a transversal here, I can see that consecutive interior angles are supplementary. Therefore, I know that AB is parallel to CD. Okay, B, they gave me those given sides. Those are not opposite sides that are congruent. So I cannot say that HIJK is a parallelogram. Number 2 here, 2A, what do they give me? That EF is congruent to GD and DE is parallel to FG. So all this statement here tells me is that these two angles are supplementary because they're consecutive interior angles. And unfortunately, that is not enough. I would have to know either also that angles F and G are supplementary, or I would have to know that angle E is congruent to angle G, and there just is not enough information there for me to know that. And finally, on 2B, with those given angles being congruent, if I think of LN as a transversal, then because of this angle and this angle, I know that AL is parallel to DN, and then because of this angle and this angle being congruent, I know that AN is parallel to AD, and that's the definition of a parallelogram. Both pairs of opposite sides are parallel. So that one's a yes. We have just a few more problems here and a proof. So I really think you can do these on your own. So okay, I'll do the first one. Why don't I do the first one? What values of the variables for what values of the variables must ABCD be a parallelogram? Well, I know that if ABCD is a parallelogram, that angle A is supplementary to angle B. So that tells me that 3x plus 10 plus 8x plus 5 has to be 180. So we can solve for x right there. We get 11x is 180 minus 15, so 165. So that means x has to be, let's see, 11 goes into 16, 1, and that gives me 55. So x would be 15. And then I know that angle D has to be congruent to angle B if this is a parallelogram. So the measure of angle B has to be, let's see, 8 times 15 plus 5. So let's see, how much is that? 0, 4, 120, 125. So the measure of angle D, I say 5y equals 125. So y has to be 25. So those are my two values. So I want you to do the next two problems. They should be similar, and then take a stab at that proof and come back and check your work. Okay, let's see how we did. In this problem, we just had to set our opposite sides equal because we know that opposite sides of a parallelogram are congruent, and I started with AB and CD so that I could quickly solve for y. I got y as 11, and then when I set AD equal to BC, I just plugged in my value that I got for y, ended up with x equals 3. So x is 3, y is 11 is what I got for that. And then on the next problem, I know that these two angles that they have marked here, this one and this one, if ABCD is a parallelogram, then I know that those two angles will be congruent because AB is parallel to CD, and those are alternate interior angles. So when I set those two values equal, I get x equals 24. And finally, on the proof, they tell me that triangle TRS is congruent to triangle RTW. So I just hopped right in there, picked out my corresponding parts, and it just so happened that those corresponding parts are opposite sides of that quadrilateral, making both pairs of opposite sides of that quadrilateral being congruent, and that's how I know that quadrilateral is a parallelogram. Okay, keep practicing, keep studying those flashcards, and we'll see you next time.